All right, happy Thursday. So a couple housekeeping notes. Tomorrow, if you're around from 2 to 3, there's two fun talks. Estimating and contextualizing riders' emotions in self-driving vehicles by one of our assistant profs in IMSE, and seamless integration between design and analysis of structures. Another assistant prof in mechanical engineering here. So those around if you're interested in the PEC with food provided. Not too bad if you're here, right? So they're going to try and do Friday assistant professor research talks to get the assistant profs telling more people about the cool stuff they're researching. I think is the plan. So, and hey, there's food, so that's cool, right? Right, and then other cool things here. The library. I was talking to someone about different books that are available. If you like books, this Skillsoft Books site is actually super cool, and they have all sorts of programming books. If you're into programming or really anything technology-wise. So if we just go search like Python, we get, I think it's like 5 pages of books here. They're relatively newish. A couple of them are a little old and stale, but most of them are pretty decent here. So if you like doing other cool things, what just happened? No, I wanted Python. Oh, the other page finally loaded. Okay, but yeah, like basically anything in IT, they've got books for it if you're interested. But specifically, yes, search if you want more Python things or something about that. Right, their website's really sad and slow, but that's fine. Nope, I can't spell pandas. Like if you want to look up pandas, right, basics, pandas in action. So these are 2022, 2021, so pretty close. Data wrangling with pandas, Python data analytics with pandas, NumPy, and Matplotlib 3rd edition from just last year. Look at that. So they got some fun stuff out there if you're looking for more things. Again, the way this course was designed is it's computer science 2. So it's computer science fundamentals, because you still need to know computer science things. We just teach it in Python, because Python's much nicer and you'll be using it more than C++. But basically the same class we do in C++ in the track. So that's available if you ever want to check out other things. I think someone had mentioned R as well, R programming. I think there was some stuff on R. This one's harder because it's just the letter R. It's like, if you go name your language, single letters, there we go. Art of R programming, R all in one for dummies. So a bunch of cool stuff out here for R as well. Oh, this was the morning class. I should share that with them. But we got some cool stuff out there. All right, so we're going to finish up talking about Deques now, was the last on the list. We did our stacks, we did our queues. Not too much more today, so it should be pretty quick. And then we're working on the checkers project as well. So that's coming up sooner rather than later. What is it? 20th, so 2 weeks, right? But get started on it. Let me know how that goes. And if you got questions on the labs, let me know. We did some of the lab stuff on recursion in lab, little demo on Tuesday. I didn't get it all written out, right? That was for you to finish, but that was the idea with it. That was more complicated than checkers is, right? Because we had to deal with the position class and then sorting the position class to get it in the order that we wanted for the Warnsdorf's rule. So it's a bit more of a complicated example there. But checkers, there's a lot to it still that we're going to work through. But that was probably a little harder than it. I don't know if that makes any sense. So, all right, so we pull up PyCharm here. So we finished with our circular queue. And I don't know if you're following along in the text here. He's got his example of the circular queue. He did the smarter math than I did. I couldn't think of right away. When he was resizing, right, this little bit here of going off the modulus, off the length here. So you can always just add one and this would resize it. So you didn't have to do from the start to the end and then from the start to the wherever you were. You could just go off of your modulus, which was cute. So again, lots of different ways of going about it here. So whatever you think makes more sense to you, it gets the same job done. So we're okay. So we had our circular queue, and the last piece we wanted to do here was our deck class. We're going to write our class for deck, which is a double-ended queue, right? So if it's going to be a queue and we want to manage our memory efficiently, we want a circular queue, because we looked at why this performs better, right? We know this one performs better than just being the straight list and that sort of thing. Especially if we're going to be able to add to the front, you need to be able to not get stuck at the front, right? Because then we'd always be resizing to make room at the front of a list. Like inserting at 0 of a list we know is slow. So being circular gives us the advantage that this just works really quickly. So let's actually, I'll just copy all of this here. We'll call it a circular deck because that's fun, right? Let's do circular deck. So with the deck, we get a couple other pieces of information here, or a couple other functions, essentially. You get adding the first or adding the last, deleting the first or deleting the last, and then getting the first, getting the last, getting if we're empty or not, getting the length. So the way we access them is a little bit different, right? We'll keep our resize, that should be fine, should work out okay for us here. Now NQ, right, is really add to the back. So this is add back, right? DQ was front, or remove front, right? Front is fine, and is empty is fine. Oh, we forgot length, that's okay, we can add in length in a little bit here too. Now back then is going to return self.data from self.back, right? But we might want to make sure we're not is empty on these things. Again, might be a good check here. So we can check if self.isEmpty, raise a index error, probably is easiest here. So check to make sure that we're not empty before we try and get these things. Because we have values for back and front, right? When we create our new circular queue, back and front are 0. So the values are there, but if there's nothing there in the data, we have nothing to give them. So we could just return the none maybe, but it's probably better to raise an error and say, hey, you tried to get something that doesn't exist. This is just no good for us here. So adding to the back was fine. This should all work the same way it did before, but now we need an add to front, given an item. So adding to the front means we're going to have to bump front first, right? We can't put something in that front index because something's there. So we need to back it up an index, or this direction, right? And then add something at that spot. Is that a question?
No.
Oh, okay, sorry. So we're going to take our self.front, and we're going to subtract 1 from it. But we might have gone less than 0, and that's not good for us now, right? Technically that would work, right? You could use the index of -1, but then all of our other stuff I don't have a lot of confidence would work the way we expect it to do. I think I'm expecting positive integers on how we resize things and check for greater than and less thans, and back will never equal that, right? And we check if we're empty or not. We said, is front equal to back? Back will never be -1. So it's probably a bad idea. Let's just avoid that, right? So we can then quickly say and check, hey, if self.front is less than 0, we'll take self.front and we'll change it to the length of self.data -1, right? So go move it, right? So wrap back around at the end and then take the 1 off so you're not, right, not hanging off the end, because there is no index at length, right? You have to go back by 1, okay? So we add to the front, we add to the back. Let's see, we're going to do our resize. So when did we check for resize? So I think we just added here before checking to see if we needed to resize, right? We checked to see, because I want to make sure we don't run into the back of the list before this happens. Right? So I guess having a length would be useful then, right? We can add a little length function. So we can define length. So how many items do we have? Right? Well, it's going to be the front to the end, or front to the back, and then if it wrapped around, right? That was the crazy arithmetic we had to do, if we wrapped around or not, to find out how many items we had. Let's see, I think he had a nice way of doing it. We can steal his math, right? Instead of having to solve it ourselves. Let's resize. Oh, he just kept track of size, okay. Well, that can work. It seems like we could just calculate that, though. Is it easier to just count? We can do that too. Sure, why not? So we'll have a self.number of items. Why not? And then every time we go and add an item, just take self dot number of items plus 1, right? And we add to the front. We should also take our self number of items as 1. That works out pretty nice. So then we don't need to check to see if back is front, right? We could just say, hey, if my number of items equals the length, we can resize. That's one way to check it, I guess. I think this should still work, right? But now for front, I guess we should check to see if we've reached the size first, if we need to resize. That might make this a little easier here. So we can say, hey, if my self.number of items is equal to the length of self.data, then we can resize. Right? Just in case. So this is probably a little easier to check. And then if we're going to do this the same thing and add front here, you don't want to have the same code twice because we'll feel bad about ourselves, right? Yeah, we should feel bad about ourselves. So let's make a function out of it, right? We could do it the easy way. We can right click here and you would say refactor extract method. Let's call this check size or check capacity. That's so it's going to turn it into a function for me. So the tool does the work for me. So it took the thing I had highlighted. Where did it put it? Put it at, where did it go? Uh-oh. Move front, add front. Oh, right here, check capacity. It put it right here. And it said, hey, I found that same code over here. You want to replace it as well? Yeah?
So I kind of forgot from like last time. So when we were talking about like the back and the front, we were talking about how like it adds to the back first, then the front, right?
With a queue, you take from the front and you add to the back because it's a line. Yep. So normally, what we had done before was you would take from the front and you would add to the back.
Yeah.
And then because it was circular, right, eventually we would wrap back around, so we want to save our memory usage and not have to be a larger list than we need. So the back might be in front of the front, but we're tracking where the front is and where the back
what
is.
We did before lists, right? Now we're doing for queues.
So we're still using a list behind the scenes, but it's a queue because we only give you methods to get the front thing and end queue, add to the back. Right? This will be the deck. You can get the front thing, you can get the back thing, you can add to the front, you can add to the back. So we're giving you access to both sides with the deck here. So I think I want to make this one, I should have...
Is that the theory of it? Where in the industry, of course, on different scale, they actually implement it like that?
Yeah, decks are pretty common. People will use those for certain things.
Codes like this?
No one would write their own, no. Right? We would go and import queue, or import deck. That's what we do in the real world, but we're spending the time writing it ourselves to hopefully better understand why they perform the way that they do. And it's a fun thought exercise, if you think that's fun. It's entertaining sometimes. And I forget, from year to year to year, I forget how these things work, and I have to relearn it. Like, you don't do the math all that often, but that's okay. All right, so for check capacity, we'll check our number of items. If it's equal to the length, we'll resize. That's easy, right? If we ran out of room, resize, and we can do that same thing in front and back to save ourselves some hassle here. So now I know I'll have the capacity, so I can change front to be front minus 1, right? Or length minus 1. So I can get to the end here for my front. Then I can go take my self.data at the self.front and assign the item. So this makes it wrap around for me, right? So make sure I have enough room so I'm not full, because if I was full, my front would hit the back. Bad stuff would happen. So I've got at least space for one more here. So let's go take one away from front, because the current front was the front item. There was an item here, right? And then we'll go put that item here in the queue. Does that make sense? Okay. Now, the weird case here, which still works, if my queue is empty, we make a brand new queue, and I call add to front, it'll actually put it at length minus 1, and that'll be the front, because back is still 0. But that's okay, because I still have one item there, right? I know where the front is, I know where the back is. That's all. So I think we're in okay shape there. So when we remove from the front, we need to take our self.number of items minus 1, right? And now we can also remove from the back. So that's removing from the front. Define remove back. So if we're empty, raise an error here. If not, do all these things, right? So get the item at self.back. Now, but back is where the next item should go, right? Because when we were adding to the front, when we were adding to the back, we would put it in that location and then increase back by 1. Right? So we put the item at where the current back was, and then we increased back by 1. So the item's never actually at the index of back. Right? This is going to be the next position for it. Right? So when I want to remove from the back, I don't want to take from back because there's nothing there. I want to take from self.back minus 1 first. Right? Let's move that up 1 in the list here. Now we might get to -1 and we have bad things again here, right? So we can go check, hey, if that hit -1, where did I have that? I was going to copy paste, but that's fine. So if self.back is less than 0, my goodness. Self.back equals the length of self.data minus 1, right? Remember, back was going to be the next location where we were putting something. So we had to back it up 1 to where the actual last item is, not where the next new item goes, here. And then I can return that piece of information here.
Because the next element is going to be like the last minus 1.
Yeah. And then we'll set that value to none. We've already decreased it. We don't need to change front at all, right? And we don't need to change any of that. We already did all that. Nope, self.not data back. There we go. The auto suggest was bad there. So go decrease back, wrap around if we need to, grab the item, set that location to none, decrease the item count, and return the item. So now we have the front, we have the back. So we shouldn't actually do back here either. We need to do back minus 1.
Why so?
Because remember, back is going to be where the next item should go.
Yeah.
This is the way we're tracking it. So there is no item at back. That's where the next item will go. Because we never really were accessing the back before. We only accessed from the front. So now we're accessing from the back. We're tracking the next open spot instead of the last item. So we could adjust it if we wanted to and actually track where that item is or something.
For set front, we should do +1.
From where, I'm sorry?
For front.
Well, so front was always going to track where the front item was. So when we added items, we added to the back,
Yeah.
right? We just increased back. We never changed front. When we took that front item, then we would start increasing front. So as you take something from the front, then we move where the front of the queue is, right? Because this one was gone here. So just the order was a little bit different. So we were tracking the index of the actual front item here. All right, oh, and then length was return self.number of items. I feel like we just do math, but this is fine. This is probably easier than doing math. All right, should we try our deck? See if we can add to the front, add to the back. Here, so we had our stack of fries. We had more fries. Let's do in the middle of that. So let's make our deck. What do they call it? A circular deck, right? And then we want to add stuff to it. So we can say deck.add. How about add to the front? We'll add a 1. Deck.add to the back. We'll add a 10. And then we'll add to the front. I think we'll add 0 to the front. Right, so we should have 0, 1, 10. Right, or 0, 1, and 10.
Yeah.
Right, so then if we print deck.front and print deck.back, check the back item, and then how about while not deck.isEmpty, print remove front, or how about remove back? We'll remove from the back and see what we get. See if we get 10, 1, 0, right? So we can say front.
Can you also print the deck?
So printing deck, if we don't add a string override, will give us that garbage that says, hey, here's the name of my class at this memory location. So if we wanted a way to print it, we could add in our own method here. Probably could do that without too much trouble, right? It's just go through for each item. Yeah, we probably could, but generally you don't give access to everything. Like showing everything, printing it all out would give you access to all the items. It sort of defeats the purpose of restricting access to it.
Yeah.
There we go. All right, so front and back. And then we'll print taking from the back. See how that goes. So the front is 0, back is 10, and then taking from the back, 10, 1, 0. Okay, seemed to work so far. Should we add some more items?
Good.
Yeah, sure. Let's
7.
add a 7.
7, 14, 49.
All right, so deck dot add to the front to the back.
Back, back, front.
Back, back, and front. So 7. Deck dot add back. 14.
49.
Deck dot add front. 49. Okay, and then how about we pull from the front? From front. Remove front. So we should get, if we added to the back and it was empty, we should get 7. Added to the back was 14. Added to the front, we should get 49, 7, 14, right?
What other ones are right there?
We already removed them.
Oh, remove them.
Yeah, removing will get rid of them here. That's the only way to get the items out.
Like 1, 7, 14?
Should be, if we added 49 to the front,
Sorry, 49, 7, 14.
and then the 7, and then the 14. 49, 7, the 14. This is why we're failable at this, right? Humans are bad at this sort of thing. We're probably going to get it in the wrong order. Right? Writing a unit test for this would be a little bit nicer, but again, it's not super useful right now at this point because we're just building these for fun. They're just toys, right? We would use the actual deck from their library. Okay, so we've got that circular deck. So I think that worked out pretty well. That was his other one, right? Just making sure we looked here. Let's see. Yeah, he wants to take the front plus the size minus 1, modulus the length of the data is the back, and the front is front minus 1 modulus the length of the data when we set front. So you never need to know where the back is if you always go off of size. Well, that's fun. So you can avoid tracking another variable. Again, it gets the same job done. It's just different approaches of doing it here, right? And then we got our functions here. We got those ones. Yeah, that's actually it for the deck. It's just showing you other things you could do. You could append left, or append, pop left, or pop. So in the deck class from the collections library, they're named a little differently here, right? Versus first and last. You get them by index. Now, you can get stuff by index too in the deck class, which is weird. Like, why would you use a deck if you can do that? But sure, why not? How do you feel about stacks and queues? They're very specialty. Like, if it fits the problem we're solving, we can use it. That's all it's for. So keeps you from doing things you shouldn't be able to do, or keeps other people from doing things they shouldn't be able to do. So maybe not even necessarily for our code that we're writing, but if we're giving, if someone else needs to use this piece of code we're writing, we only want them to be able to interact with it in these ways if that's how it should be interacted with, right? So a little bit weird, but that's the gist of the deck class. All right, how's it going with the checkers project? I know we only had like 2 days, but did we look at it yet?
Haven't started yet.
Okay, it's all right, we got some time. But definitely start it. So bring your questions next Tuesday to our lab time. That's a good time to answer questions. You folks were great, but my other class got really confused, and I got like 4 emails from people that are like, I spent all my time working on the lab, can I have more time on the project? I'm like, no, the project's due because I'm going to go over the solution. If you need more time in the lab, I'll give you more time in the lab. I don't know where the confusion was, but okay. Yeah, so let's focus on that. Bring your questions next Tuesday about checkers. We can talk about it then in lab time. And then we can go from there, okay? All right, awesome. Yeah, it's pretty short, so hopefully there's still some hot chocolate over by the UC. They had some bonfires going, which would have been fun if it was really cold out, but now they just smell bad.
Don't you like the smell?
I do. I used to camp all the time because I was a Boy Scout. So like once a month we'd go camping all the time. And I did like that. But they were like super smoky and not very fiery because I don't know, like, whatever.
How did you make it like up the ring?
I was an Eagle Scout.
You were an Eagle
Yep.
Scout?
Or still am an Eagle Scout, right? Once an Eagle Scout, always an Eagle Scout. I'm not active at the troop anymore, which is a bummer, but it's okay. Life got busy.
You still like camping?
When I had 4 kids, we went camping a lot. When we adopted number 5 and 6, it did not work so well. One, because my daughter's in a wheelchair, and that's hard to camp in.
I see.
And 2, the little guys, just a handful. So not so much anymore. Our version of camp is in a cabin.
You have 6 kids?
7 now.
7.
Yeah,
All
but
right.
with the 4 kids, we liked camping a lot. That was fun. We did a bunch of things. We did a road trip out into DC and back, and like every other night we'd camp because it was cheaper, and the other nights we'd get hotels so we could shower.
I see.
But that was a fun trip. That was pretty cool.
Like you're a good planner. I mean, like I never really thought about like every other.
Well, my wife planned all of
So
that.
that's
She
a good thing.
she had the whole itinerary planned out, and it was really cool.
Interesting.